Hi there, in this video we're going to talk about partial sums of an arithmetic sequence. So what is a partial sum? So we're going to illustrate that with an arithmetic sequence. If I have a sub n equals 8n minus 6, the question says find S4. So what is S4? So this is when you see this, it means the sum of the first 4 terms. So let's find the first 4 terms. So A1 would be 8 times 1 minus 6, which is 2, a sub 2, and from here we can just see that the difference is 8, right? So the common difference is 8, so a sub 2 is going to be 10, a sub 3 is going to be add 8, so 18, a sub 4 is going to be add 8 again, so what is that? So that will be 18 plus 8, which will be 26. So those are the first 4 terms. So if I was looking, so the reason it's called partial sums is S1 will be just the sum of the first term. So it'll just be 2. There's not much to do there. S2 is the sum of the first 2 terms. So it'll be 2 plus 10. S3, the sum of the first 3 terms. So 2 plus 10 plus 18. And finally, for our question, it asks us to find S4. So it's 2 plus 10 plus 18 plus 26. And so adding these up is going to give us our S4. So put that in the calculator real quick, which we get 56. So that will be, we were asked for S4, so this will be S4, the sum of the first 4 terms. So that's what a partial sum represents, is the summing, the addition of n terms. So Sn is the sum of the first n terms. And so to illustrate, to come up with a formula, I'm going to use just a standard sum to say I have a sum of the first 20 terms of something very simple, an arithmetic sequence that just increases by 1. So 1 plus 2 plus 3 plus 4 plus 5 plus 6, and so on, all the way to 20. So if I want to add these up, of course I can just add them all up, but I'm trying to come up with a formula. So what I'm going to do is, and bear with me here, I am going to reverse this sum. So this sequence of numbers, I'm just going to reverse it. So instead of starting at 1, I'm going to start with the last one. So 20 plus 19 plus 17 plus 16 plus 15. So notice that they're still the same numbers. I'm just putting them in reverse. So plus 1. And the reason that I'm doing this is just a mathematician a long time ago came up with this method to find the sum pretty quickly. So if I add them, so s plus s gives me 2s, and now add everything on this side. So notice that the reason that they're lined up like this was 1 plus 20. I get 21. What's 2 plus 19? 21. What's 17? Oops, I skipped a number, didn't I? That should have been 18. So I skipped a number here. So 18, 17, 16, 15. Okay. So now notice that everything is adding up to 21. 19 plus 2 is 21, and 20 plus 1 is 21. So my question is, how many terms do I have here? Well, I started with 1 and ended at 20. So we have 20 terms. So that means that I have 2s is equal to, I'm adding 21 20 times. So it's 20 times 21. Divide both sides by 2 to solve for s. And my s is for sum. So s is 20 times 21 divided by 2. which in this case, it gives us, what's that, 10 times 21, so 210. So that will be the sum of the first 20 natural numbers. Now, what if, just to illustrate it a little bit even further, what if the first 50? So I will say S is equal to 1 plus 2 plus 3 plus 4 all the way to 50. And let's do the same thing that we did before. Let's reverse it. So 50 plus 49 plus 48 plus 47 and so on, plus 2 plus 1. So now doing the same thing, I get 2S is equal to 51 plus 51 plus 51 plus, and so on, right? So how many terms are here? There's still 50 terms. So I have 50 terms. So I'm adding 51. And the reason that I listed the number of terms is because it's all 51. So I'm adding 51 50 times. So that becomes a multiplication problem. So it's 2S equals 50, right? The number of terms times 51. And so again, solve for S. So again, my 50 divided by 2 times 51. So the pattern seems to be there. So I want to dissect it a little more. Where did the 51 come from? The 51 came from doing our A1 and our A50. Right? Notice that this, when I reverse it, this is my A50, A49, and so on. So the 51 came from doing A1 plus A50. And so in general, I can say that the sum is going to be, what was the 50? 50 was the number of terms, so it's going to be n over 2 times a1 plus an. Right, so for a50, notice that the 50 there matches up with the a50. And for the 20, same thing, right? I can think of this as, this was a1, which was 1, plus a20, which was 20. And so this is a formula for the nth term for the n partial sums. Now we can go a little bit further and remember this is an arithmetic sequence. So because this is an arithmetic sequence, that means I know the formula for a sub n. A sub n is a1 plus n minus 1d. So now with this, we can even write the partial sum formula in terms of the first term and the common difference. So let's do that. So S sub n will be n over 2 times, I'm going to use bracket here, a1 plus a sub n. And using the formula for the arithmetic sum is a1 plus n minus 1t. And simplify it. So it'll be n over 2 times a1 plus a1. Those will be like terms, so it's 2a1 plus n minus 1d. So this will be the formula. So we have two ways of finding Sn. Sn is equal to n over 2 times a1 plus an if you have the first and the last term. But if you don't have the last term and you have a common difference, then we can say Sn is n over 2 times 2a1 plus n minus 1d. So this is in terms of the common difference. So let's try an example. So for this example, we're asked to find S20. So the sum of the first 20 terms of the arithmetic sequence, 3, 7, 11. So notice that it just goes dot, dot, dot. So we don't know the 20th term. So I can't use the first formula because I don't know a sub 20. So I'm going to use the second one because I do know a sub 1. We know a sub 1 is 3, the first term, and I can figure out the common difference. How do I find the common difference? Well, do 7 minus 3, so that's 4. And then just make sure that it stays the same. So if we add 4 every time, it looks like that's working. So the common difference is 4. And so we can say then S sub 20 is equal to, so that means n is 20, right, for S20. So S sub 20 will be n over 2, so 20 over 2, times 2a sub 1, a sub 1 is 3, plus n minus 1, n is 20, so 20 minus 1 times the common difference, which is 4. And then simplify this out. So I'm going to get 10 times, what's that, 6 plus 19 times 4. And when you do that on a calculator, 19 times 4 is 76. And so we get 10 times 82, which is 820. So that will be the sum of the first 20 terms. So essentially, what this means is that you're adding, so the first terms are 3 plus 7 plus 11 plus 15 plus 19 plus 23 all the way until the 20th term. So when you add this, you're going to get 820. So the nice thing about the formula is that essentially we don't have to know what all these missing terms are, because with this nice formula we can figure it out without knowing all of the terms. And so let's try a second example. Okay, so for example 2, find S sub n, the partial sum for an arithmetic sequence with a sub 1 equals -2, d is 23, and n equals 25. So this one, we are given d, so we can use that formula. So Sn is equal to n over 2 times 2a1 plus n minus 1 d. So we really only use the other one if we know the first term and the last term, because then we can just plug them in. So n is 25. So that means we're finding S25, the sum of the first 25 terms of this sequence. So I'm going to have 25 over 2 times 2a1. a1 is -2, so 2 times -2 plus n minus 1, so 25 minus 1 times d. d is 23. And we simplify this. 25 is not easily divisible by 2, so I'm going to leave it like that and hoping that this is an even number. 2 times -2 is -4, plus this is 24 times 23. So 24 times 23, when you do that on the calculator, you get 552, or if you do it by hand. And so I get 25 over 2 times -4 plus 552 is 548. It's essentially 552 minus 4. And yay, that's an even number. So I can do 2 into 548 and then multiply by 25. And this gives us 6,850. So that means that the sum of the first 25 terms for this arithmetic sequence is 6,850. So that's how we do it. Now, if you wanted to use the other formula, with this information, we can also find the 25th term, right? So I know my other formula is n over 2 times a1 plus an. So for, in our case, it will be 25 over 2 times a1. We know a1 is -2 plus a25. So what is a25? So we can find a25 by doing the formula for an arithmetic term. So it will be a1 plus n minus 1 times d. So this will be -2 plus 25 minus 1. So it's 24 times d, which is 23. And so now we can figure out what that is. Which we already know from up here that 24 times 23 is 552. So I have -2 plus 552, which gives us 550. So when I go back to our formula here, it's going to be 25 over 22 times -2 plus a 25, which is rounded to be 550. Right, and so notice that we get the same thing. So it's 25 over 2 times -2 plus 550 is 548, which is now the same math that we did over here. So we're still going to get 6850. So you can do it either way. Let's try another example. All right, so here's example 3. Find the number of terms needed in an arithmetic sequence to get a sum of 2700 if the first term is 12 and the common difference is 8. So in this case, what's new? We are given the difference. We're given the sum. So S is 2700. We're given the first term. So A1 is 12. And we're given the common difference. D is 8. So using the formula as n is equal to n over 2 times 2a1 plus n minus 1 times d, we can try to solve this. So we don't know n, so we want the value of n. And how do I know that? Because it says find the number of terms. So the number of terms is n. So that's what we want to find. So I know this is 2700 is equal to, I don't know n, so n over 2 times, we do know a1 is 12, so 2 times 12 plus, we don't know n, so that has to stay. And the common difference is 8. And let's simplify this. 2700 equals n over 2 times, let's see, what do we get here? 2 times 12 is 24 plus, distribute the 8. So I'm going to get 8n. Don't forget to distribute to everything, minus 8. So I get 2700 equals n over 2. Combine like terms on the inside here. So 24 minus 8 is 16 plus 8n. Okay, both of those are even. So that means when I bring in this n over 2, I'm going to be able to reduce the 2's. So I'm going to get 2700 equals 16n over 2. So 16 over 2 is 8. So I'm going to get 8n plus n over 2 times 8n. The 2 and the 8 reduced to 4. So I'm going to have 4n times n is n squared. And so this looks like a quadratic. And I do notice that I have a coefficient of 4 here. 4 does go into 8. So check, does 4 go into 2700? The fact that we have 100 there, I do know that 4 goes into 100, so it's going to go in there. So really quickly do 2700 divided by 4. And when we do that, we get 675 is equal to n plus n squared. Right, so divide both sides by 4 here. And now we have a quadratic. So to solve a quadratic, set it equal to 0. So subtract 675 and rearrange this so that it's in descending order. So n squared plus n minus 675. And hopefully that factors, and it should, because n, remember this is an arithmetic sequence. So this is the partial sums of an arithmetic sequence. So our n's are natural numbers. So counting numbers. So my n should be a positive counting number. So it should factor. So I'm looking for two numbers that multiply to negative 675 and add up to, that should have been a 2. plus 2n, right? 8 divided by, when I divide by 4, 8 divided by 4 is 2. So two numbers that multiply to negative 675 and add up to 2. 675 is divisible by 5, but it's also divisible by 25. So when you divide by 25, you'll see that 25 times 27 gives us 675. So this factors into n plus 27 and n minus 25. So now using the zero product property, either n plus 27 is 0 or n minus 25 is 0. This one gives me n is minus 27, which can't be. Why not? N is supposed to be a natural number. Natural number are the positive counting numbers. So it can't be that. And this one says n is 25. So our answer is 25. So we need 25 terms of that arithmetic sequence to get a sum of 2700. So this one is no, because n has to be a positive counting number. A quicker way to say that it has to be a natural number. All right, and that concludes section 12.2.